Hi, my name is Elise and I'm a senior here at Iolani. My mentor is Dr. Christian Sexton, and my research project is analyzing drone data to better understand the behavior of great white sharks in nearshore waters off Cape Cod. So why is it not changing? Oh, okay. So why is this topic so important? Well, when most people hear great white shark, they get scared. They think dangerous or maybe vicious, and there's often a strong association with movies like Jaws. But who can blame them? There's so little information available or well known on great white sharks that the world's perception of these animals is centered around the inaccurate and over-exaggerated portrayals in the media. Right now, most shark mitigation systems, which help people to stay safe from shark attacks, right now, most systems or plans to keep people safe from sharks while allowing recreational water use rely on interaction with the sharks themselves. For example, a shark net is placed in the water to keep sharks out of a certain area. It blocks them from their natural habitat, and it oftentimes harms the sharks themselves along with other marine animals. Overall, with my research, I hope to be able to lay the foundation for the creation of a non-destructive shark mitigation system using drones to be able to detect sharks, analyze their behavior, and warn swimmers of impending danger. This past summer and school year, with the help of my mentor, I started laying the foundation of this research by determining the accuracy of drone altitude, collecting data, and analyzing the data from 32 different sharks. Past research in this area has focused mostly on tracking sharks in relation to the shoreline, whereas for my research, I focused on improving the data collection methods, finding the drone accuracy, as well as determining the shark speed, length, and tailbeat frequency. I'm also attempting to work towards a shark mitigation system. So just some background information on Cape Cod and why sharks are such an essential conversation to have. In 1972, the Marine Mammal Protection Act was implemented. This act prohibits the endangerment of marine mammals, including harassment, hunting, capturing, collecting, and killing, in order to prevent the extinction of certain populations. This caused a dramatic increase in the seal population along the coast of Cape Cod. This significant rise in prey brought a growing population of great white sharks in recreational water areas in Cape Cod. Therefore, the chance of a shark attack in these recreational areas rose, and it will likely continue to do so in the future. To put this information in perspective, since the year 1751, there have been 21 unprovoked shark attacks in Cape Cod, and 10 of those attacks have occurred just since the year 2000. While the rising number of shark attacks is a problem due to the decreasing safety of recreational water users in the area, it also leads to an even greater negative perception of great white sharks. People's misconstrued ideas about sharks fuel destructive shark mitigation tactics while simultaneously lowering support for shark conservation. Great white sharks are apex predators, meaning they exist at the very peak of their marine food chains. Apex predators are essential to the stability of their given ecosystems. They keep prey populations balanced and in check by providing negative feedback loops. And great white sharks are no exception. They're incredibly important to our marine ecosystems, and without them, the health of the coral reef would decline rapidly. While Cape Cod itself does not have a coral reef, great white sharks are part of many marine ecosystems around the world, which is why it's so important to keep them safe. The first step to making my project successful was to know the accuracy of the measurements from the drone. The altitude of the drone is an incredibly important parameter to know in order to find the length of the speed as well as the length and the speed of the sharks. The altitude given by the drone is determined by a barometer, which provides a large source of error. To quantify this error, the true altitude of the drone was found using a laser rangefinder and compared with the given altitude from the drone. On the first graph, you can see that the error ranged between -15 and +10 feet. On the second graph, it shows how I determined the optimal altitude for data collection, which is between 100 feet to 200 feet. And this was done by minimizing the measurement error due to altitude error while still maintaining an adequate resolution on the computer screen in order to mark the outline of the shark. At this data collection altitude, there's an estimated error of 1 foot on a length of a 10-foot shark. It's also very important to run correlation tests to ensure that the drone's speed and that the drone itself was not affecting the measurements that it was collecting. So the drone's speed and acceleration, as well as the shark position on the screen, was plotted with the speed of the shark in order to show whether there was correlation between the two data sets. This verified that the drone's speed, acceleration, and position had no effect on the outcome of the collected data. My next goal was to find My next goal was to find sharks and collect data. So how was the data for this project collected? Well, this past summer, I earned my drone license by passing the Federal Aviation Administration Small Unmanned Aircraft General Test. After receiving my license, I was able to collect video and flight data of great white sharks using a commercially available DJI Phantom drone throughout the summer during my K Fellowship. The drone was flown along the shoreline of several beaches in Cape Cod. While searching for the shark, the drone was flown at about 300 to 400 feet above the water in order to spot the sharks. This increased the field of view and therefore increased the probability of actually seeing a shark. Once the shark was spotted, the video data started to be recorded and the drone was lowered to between 100 to 200 feet above the water. Throughout this whole process, the gimbal angle, which is the angle of the camera on the drone, was kept between 70 to 90 degrees, with 0 degrees being straight forward and 90 degrees being directly down at the water. The shark was also kept in the center field of view of the camera for as much of the tracking as possible. All of these variables help to increase the accuracy of the video analysis and resulting measurements. My last goal was to analyze the drone footage using proprietary software. Video data was annotated using a semi-automated process in Python. The lengths of the shark were found by marking points from the nose to the tail of the shark along the center line of its body. Measurements were taken when the drone was 100 to 200 feet above the water and directly over the shark, where the shark was near the surface, clearly visible, and the camera was pointed directly down. The objects were marked on the screen, and tracking was performed using a mean shift algorithm. The shoreline positions were determined by flying the drone along the shoreline and capturing video data within 20 minutes of shark tracking in that area in order to determine how close the shark was to shore. And this was done without any interference from the tide, since it was done within a short time away from tracking the shark. So as you can see in the video, there is a shark swimming along, and it's marked by a blue box. And you can see the shark's distance from shore, the shark's speed, as well as its tailbeat frequency. And on the right-hand side, you can see the total track of the shark as it swims along the beach, along with its length of 11.5 feet. So every parameter in this video was found separately, and then they were combined into one video. The analyzed videos and flight data from the sample size of 32 sharks shows lengths ranging from 8 to 13 feet, speeds ranging from 1 meters per second to 1.79 meters per second, and tailbeat frequencies ranging from 0.31 hertz to 0.63 hertz. On these graphs, each bar represents a different shark. As you can see on the length graph, there's quite a few bars missing from the graph. And not all lengths were found because I limited the measurements to sharks that were clearly defined and easily marked. So any shark that was in too deep of water or was in murky water was not included in order to keep the data as accurate as possible. The majority of the sharks are adults in Cape Cod from what we found in this study, which means that they are of the size where they start to use seals as their main type of prey, and this means that they pose a possible threat to human lives. The swim speed of a shark is very important because it can characterize the behavior of that shark. So slower speeds, which minimize energy per unit time, are characteristic of hunting behavior, while faster speeds, which minimize energy per unit distance, are characteristic of travel. Speeds observed in this study appear to be lower than the optimal travel speeds, which means that it's very likely the sharks were hunting. Similarly to the speed, the tailbeat frequency can indicate behavioral patterns. However, unlike the speed, tailbeat frequency is independent of current. This data and research is a step in the right direction for the safety of both humans and sharks. As you can see in the video, on the right bottom there are people swimming through the water, and on the top left there is a shark swimming through. It's kind of just a dark blob because it's not loading, but so with a drone warning system, they could be alerted and evacuated from the water to minimize the chance of a shark attack with no disturbance to the shark itself. Overall, drones in this study appear to be highly effective in shallow and relatively clear water. In future work, I hope to quantify exactly how accurate a drone can be by looking at the average amount of time I was able to track each shark and how they were lost, as well as what kind of conditions make it impossible to allow me to make the best mitigation system possible. My research this year was the most amazing experience, and I'm so grateful I had this opportunity to participate in both the Cave Fellowship as well as independent research. Thanks to my mentor, I learned how to fly a drone and use Python software. Furthermore, I learned patience and perseverance as I overcame the difficulties of finding sharks, as well as learning how to analyze the data. As for future independent research students, I would suggest to pick a project that you will genuinely love and make sure you don't procrastinate, because you will regret that later. I had so much fun this year, and I'm so grateful I had this opportunity to conduct research. There are a few people I would like to thank. First, I would like to thank my research mentor, Dr. Sexton, for allowing me to work with him this summer and be a part of his amazing research, as well as allowing me to use his software both during the summer and throughout this entire school year. Second, I would like to thank Dr. Chan for always supporting my ideas and pushing me through the challenges I encountered throughout this year. Third, I would like to thank Dr. Webb for writing my recommendation and always being excited to listen to random facts about my research. I'd like to thank my parents for paying for my flights and allowing me to spend the entire summer on the East Coast, as well as listening to all of the drafts and edits of my papers and presentations throughout the year. And finally, I'd like to thank you for listening to my presentation.